Alright, class, what do you do with the negative 3?
Move it to the front.
Y equals negative 3 plus 2 sine. Class, we change that to what? X. Alright, let me tell you the number one mistake that I saw on the test for graphing in the previous years. A lot of students think that they would add these two to be negative 1. If you did that, your A value would be a negative 1, but you've eliminated the D value. You eliminated the vertical translation, so you would not combine these. That's the same idea as saying like negative 3 plus 2x. Class, would you say that that is negative 5x? Or negative 1x? No, they're not like terms, so these are not the same. You would not add those. Okay? Cynthia, tell us about letters. D plus X minus C. So if I change this to be a minus sign, I would have Y equals negative 3 plus 2 sine X minus pi over 2. Kiana, your A value?
2.
B value? Correct. C value? Good. And your D value? Vita, tell me each of these letters and what it does. Start with any letter you want. And your amplitude would be what? Yep. Left or right? Why did you choose left? You can also think of it as what? Adding to x, go left. So this is left pi over 2. Remember, if you're using the formula, if your C value is less than 0, you're going left. Vito, this one? What does the B value help us find? What is our period going to be? Yeah, 2 pi over B, so B is 1, then it's just going to be 2 pi. And what does the D value tell you?
If you go up or down.
So do you think it'll go up or down?
Down.
Yeah. There are our characteristics. Now normally we have 5 values, 1, 2, 3, 4, 5, but because you're doing a shift left, your 5 values would be 1, 2, 3, 4, 5. Now, because this value has a horizontal or phase shift, you're going to have to put this between 0 and 2 pi. Now, when you move the D value over here, then you just have this right here. Everything to the what? Which direction is this? Left or the right of the trig function? Now I have x plus pi over 2. If you have not seen this, maybe this might help you. PEMDAS. You're using PEMDAS to simplify, but you're going backwards if you're solving. So right now, we're solving for x. Class, how do you get x by itself? You subtract pi over 2. This will give me negative pi over 2 x, and this will become okay, let's try that again. So negative 1 pi over 2 3 pi over 2 negative 1 pi over 2 and 3 pi over 2. We're okay so far? And then our midpoint is negative 1 plus 3 is 2, and 2 divided by 2 is 1. This is 1 pi over 2. In class, negative 1 plus 1 is, and 0 divided by 2 is 0. So that's 0 pi over 2. And then realize you're just counting by what? Ones. A student asked me this question, so I thought it would be super helpful for you. Put your finger on the C value. Put your finger where negative pi over 2 is on your graph. Okay, if you have more fingers, put your finger where negative pi over 2 is on the inequality, where the inequality is. Those are all the same, right? Would you guys agree? And if you take your period and you add 2 pi to negative pi over 2, so that would be 2 pi over 1 or 4 pi over 2. 4 pi over 2 plus negative 1 pi over 2 gives you what? 3 pi over 2. This student was trying to not use this to figure out this. Does that make sense? So that was another way of finding out these values. Okay. These are our x values. In class, what are we going to do first? What do you do with the x value? Now, a lot of things are going on, so I'm going to highlight the one we're going to use. This one right here. Although this is the original, this one looks cleaner for us. What are we going to do with the x value, class? We're going to add pi over 2. Although you are working right to left, you have to use still order of operations within the parentheses. Okay, so we're going to add pi over 2. Add pi over 2. Class 1 plus a negative 1. 1 plus 0. 1 plus 1. 2 pi over 2 is just pi. 1 pi over 2 plus 3 pi over 2. And 1 pi over 2 plus 3 pi over 2. 4 pi over 2, which is 2 pi. Yay! We have our golden row. I just made that up. I call it the golden row because it's it's the unit circle. It's the quadrantal angles on the unit circle. Partner A, tell partner B, what do we do after this now? Vita, what do we do next? Yeah, we did all this, now we're gonna evaluate sine. So evaluate sine. Vita, sine at 0. Pi over 2. Good job. Partner B, tell partner A, what do we do next? Charlotte, what do we do next? Yep. The relationship between sine and all this and the 2 is multiplication. So we're going to multiply by 2. Multiply by 2. Charlotte, go ahead and multiply each of these values by 2.
0, 2, 0,
Yep. Partner A, tell partner B, what's our last step? Eduardo, what's our last thing we need to do? Okay, before we graph it, we already had the x values. Add what? We're going to go now add -3. Or, Klaus, what's another saying adding -3? You're subtracting 3. So your d value goes last. Michelle, go ahead and subtract 3 from each of these values. What did you say? So 2 subtract 3, or 2 minus 3. Let's go ahead and graph this one. Just for fun, look at the top there at the original equation. Class, adding pi over 2. What letter was that? Class, what letter is multiplying by 2? And then subtracting 3 is what letter? D. So there is a particular order, right? Let's go ahead and graph that. Poor planning. The lowest number is -5, so -1, -2, -3, -4, -5. Remember, there's a shift, so I'm starting over here. Negative pi over 2 is -3. -1. -3. -5. And -3. Put your finger at, or your pencil at the midline. It's between your x-intercepts for sine. Where was I supposed to be at? Up here, right? Where from the yellow to the orange? How did you get there? It shifted down 3 units. And it comes along with the whole graph. Does that make sense? If you had time this afternoon, because you have nothing else to do, I would highlight each of these rows, and you can actually see the transformations of the graph as each of these things are happening. Okay? So there we graphed a combination. Vertical, I can't even fit on the screen. That's how big it is. We did a horizontal translation, vertical, and a vertical stretch of 2.